So it looks like I have 2 number 3s. Sorry about that. What is, you can take it out of my salary. What is the force of gravity on a 4.5 kilogram block of gummy bears? I tried to mix worms and bears there. F equals ma. I'm finding force, so it's 4.5 times acceleration, which is 10, and I get 45 newtons. What is the mass of a jar of pickles that is pulled down by a force of gravity of 167 at Earth's surface? So again, this is just F equals ma. I'm just given different variables. So 160 newtons is my force, mass is my unknown, and acceleration is 10. So I divide both sides by 10, and I get m equals 16.7 kg. That's a very heavy jar of pickles. Okay? Which 2 quantities are measured in the same units? Velocity and acceleration. This one's meters per second. This one's meters per second squared. Can't be that one. Weight and force. Weight is measured in newtons. Force is measured in newtons. Let's make sure here. Mass and weight. Mass is measured in kilograms. Weight is measured in newtons, so that can't be it. Force and mass. Force is in newtons. Mass is in kilograms. That can't be it, so the answer must be B. Number 6. David is pushing on a laptop cart with a force of 150. Ian is pushing back with a force of 200. The mass is 125. Draw a net force diagram that shows all forces and write a net force equation. What is the actual acceleration? So if I annotate this, I know that I need to draw, I need to write the net force equation, and then I need to figure out what is the actual acceleration. So I'm going to use a dot as my cart, because that's what we do in physics. We often use a dot or a box. David is pushing this way with a force of 150 newtons. And Ian is pushing back with a force of 200 newtons. There's my net force diagram. Now I'm going to write a net force equation. The net force on the laptop cart equals the force of David plus negative the force of Ian. Or you could say the opposite way, force of Ian plus negative the force of David. It doesn't matter. Then I'm actually going to figure out the actual acceleration of the cart. So I'm going to figure out my net force. So it is 150 plus negative 200. So I get negative 50 newtons is the net force. I'm going to use that net force to find out the actual acceleration. So if I know that F equals ma, I know that negative 50 equals mass, which is 125, times the acceleration. So I'm going to divide both sides by 125, and I get 0.4. If you were confused on that question, because I went through it pretty fast, go back and check your week handout, the notes from Newton's second law video, and then there's a flow chart that goes along with that. Okay? All right, ELR 3.5. What is the difference between static and sliding friction? Static friction is when an object is standing still. Sliding friction is when it's moving. And it's the friction, the force that opposes the motion based on the relationship between the surface, the micro welds that we talked about. Okay? Fill in the statements with a greater than or less than or equal sign. Sliding friction is less than static friction, so it's harder to get something started than it is to keep it moving because of that. And sliding friction is greater than rolling friction. Remember the bucket with all the pencils underneath it, and it was really easy to pull when it was on the pencils versus when it was just sliding across the table. Okay?